we will try and record the session. In fact, I'll start recording it now. If the recording is successful, we will make it available to users to review afterwards. ESD is environmentally sustainable development. I'm sure you all know that. Otherwise, you might not have come for this presentation. Okay, so let's, having said that, let's move forward. Just a couple of housekeeping notes. You guys are already following that, which is wonderful. Since we've got so many people, it's best that everybody keep their microphones off and also turn off your video camera because the bandwidth will be huge otherwise. Feel free to use the chat and I will monitor the channel, and every once in a while I'll just check it. And if there are particular questions, we'll try and address that as we go along. So today's agenda is really... Sorry, there's somebody there who's got his microphone on. Can I please ask them to switch it off? Right, thank you very much. Right, so today's agenda is we'll review the temperature criteria and the thermal comfort criteria that have been put out in the new National Construction Code. Then we'll look at what exactly is predicted mean vote, or PMV, as we're in its short form. And then my colleague said to me that we have to use the word magical. So because he said that the plugin is magical in the way that it works. So thank you, Akshay. I've left the word in. So we'll introduce the magical plugin for DesignBuilder. And then we'll talk a few bits and pieces about what you need to do to actually use the plugin. And then we'll finish off with an example. And I suggest we try and leave the Q&A till the end. If there are burning questions, do put them on the chat and I'll have a look at it once in a while and we'll talk through it. So if we start by looking at the criteria in the new Section-J, let's have a look at that. So obviously, you're going to use DesignBuilder if you're going to use the verification method. You probably wouldn't want to use it if you were going to use the DTS method and so on. So when you use a verification method, the most popular one is JV3, which is verification using a reference building. And the first clause, as you can see on the screen, is really this JV3 clause here. And you can see here that in clause A2, which I've put in a rectangle over there, you can see that that's the criteria that's being asked for the analysis. Now, that criteria is really for the reference building. Can I ask, there's somebody there who's got their mic on. Could we get you to mute your microphone? Thank you. Yeah. So this requirement for PMV, as is highlighted in yellow, is for your proposed building. So for your proposed building, you can see here that you have to maintain a PMV between -1 and +1. and that's got to be maintained for not less than 95% of the floor area of all occupied zones for not less than 98% of the annual hours of operation. Now, all of these are defined terms. Floor area, occupied zones, hours of operation, they all have got particular meanings within the National Construction Code. So it's good to remember that. Okay. Now, that's the requirement for PMV for the proposed building. But what you'll find is that if you go forward and you look at the specifications for doing the actual energy simulation analysis, there is another criteria which has to be met for the reference building. And for the reference building, if you look at this clause 2C and this capital B, it says the air conditioning must maintain 21 to 24 degrees centigrade in all conditioned spaces other than these transitory spaces. So the plugin actually looks to work out these temperature criteria for these conditioned spaces that you're looking at. And that's got to be done for 98% of the hours of operation. Okay, so these are the two criteria that have been that need to be met for JV3 analysis. The PMV criteria is new. The temperature criteria was there before as well, different temperatures, but there was always a temperature criteria that needed to be met. Okay, so having looked at these criteria, the next question is, what exactly is PMV? So I've got a screenshot here of PMV. It's one of the ways to measure thermal comfort, and it talks about the name is predicted mean vote, and it literally is was derived by asking people to vote for their feeling of thermal sensation. So if you look at the right-hand side of the screen, there are 6 criteria that go, or 6 variables, I should say, which go into the calculation of a predicted mean vote at any time. And these are, as you can see, air temperature, radiant temperature, relative humidity, activity, which is represented by a metabolic rate, the level of clothing that a person is wearing, and the air velocity. Now, some of these variables are in the control of yourselves when you're doing these analyses. For example, you can define how much clothing the person is wearing in summer or in winter or in the middle season, right? You can define what is the activity rate that people are having in the spaces that they occupy. So if you're in an office, then your activity rate is about 1, which is seated and doing some light work. Other things are not always in your control. You can control the air temperature, and that's by defining a thermostat setting, which the radiant temperature is not really under your control. That's a property of the building fabric. The relative humidity is controlled by the air conditioning system if you've got a system that actively controls relative humidity. The air velocity is not really in your control either if it is an air-conditioned space, then the air velocity is generally very imperceptible, and typically we use a value, it's hidden away in the engine, but somewhere around 0.1, 0.12, 0.13 meters per second is what is being used to calculate Pmv. So these conditions, I mean, these variables, the ones that you can vary, you can certainly have a, change those things around. But other than that, you have to then depend on the building fabric to control Pmv. And what you might find is that particularly if your radiant temperature is too far above the air temperature in summer or too far below the air temperature in winter, then you start to get sensations of being too cold or too warm. That's what the +1 and the -1 are all about. Okay, so now that we know Pmv, we need to start thinking about how do we apply this knowledge into our energy simulation models. So let's look at what is the energy simulation model consist of. For those of you who have attended any of my lectures in university or wherever, you know that this is a slide I refer to quite often. These are all the components of an energy simulation model. You have your building geometry, you have the materials that make up the model of the building, you define glazing systems and framing systems. You look at the internal loads in the space. So where does the heat come in from solar radiation through the transparent envelope, from heat generated within the space by people or equipment or lights, by ventilation and air exchange and infiltration. And then these loads that you're looking at, particularly the internal loads, the lighting, equipment, people, they are applied to the building model using a series of schedules or profiles. And for the purpose of the NCC, these schedules are defined. So for the use of the plugin, you need to do inputs of some of these things into the model. So let's just take a quick look at that. You need to let the model know which zones you are looking to report on. So you have to identify each of the occupied zones that you're interested in looking at performance, and you need to define its building class as what the NCC is requiring. And I'll show you where that is in the model in a second, right? So these three things that we talked about in the previous slide, occupancy, lighting, equipment, air conditioning. When is the air conditioning on and off? These schedules are provided in the section JV3 modeling profiles in the code, and you need to define these things correctly. Now, the plugin doesn't check whether you've done this accurately or not. It just looks at which hours need to be reported for which class of building, and then it develops the report. Now, if you've been reading Section J carefully, you will see that there are some small inconsistencies in the way that the Pmv has asked to be calculated. And that's because Pmv by definition has no meaning if it's not an air-conditioned space. And within Section J, in a couple of the building classes, Pmv is being asked to be reported when the air conditioning is off. So that was a bit of a problem. So what we've done is we've taken a common sense approach. We've interpreted the requirement of hours of operation when the occupancy is 20% or greater, as defined by the code, and when the air conditioning is on. Okay, and for example, if you look at class 5, this schedule is directly from the JV3. And so what the Pmv plugin is looking for is to report the hours when the air conditioning is on and the occupancy is 20% or more. Okay, so from 8 o'clock to 6 o'clock, it will report the Pmv. Okay. And if you look at some of the other classes, in the documentation that we provide with the plugin, you'll find it'll tell you in these gray squares which are the hours that it's looking for each of the cases of buildings, or each of the classes of buildings, I'm sorry. So the first thing to do is that in your occupancy schedule name, you need to put this name as part of the name. Okay, so if you're looking at a table, a class 2, you got to have class 2 in the occupancy schedule. If you're looking at class 5, you've got to have class 5 in the occupancy schedule. If there's a zone that you don't need to report or you don't want to report because it's not a zone that is conditioned, then you can use the word do not report in the occupancy schedule and it won't be included in the reporting. So here's an example of, there's a screenshot from DesignBuilder. That's where you're putting in the occupancy schedule. And you can see here that in this occupancy schedule, I've got the word in there, class 5. And it tells the plugin this is one of the zones that needs to be reported. Okay, so having done that, let's have a look at what the actual plugin provides as an output. Once you've done the energy simulation, the plugin post-processes the energy simulation output. Now, we've tested it with files as large as 1.5 gigabytes, and it works quite well. You know, you've got thousands of variables. You need to pick the variables that you want to report on. So it needs to cycle through a huge amount of data. Once it's done that, it will write for you an HTML report, and that will report whether the criteria for temperature and Pmv have been met for each of the zones of interest, depending on the class of building that you've identified. It'll give you a pass or fail report for every zone, and then it'll calculate it for the whole building. You know, 95% of floor area for 98% of the time. So it does all of those calculations for you. In addition to that, it will also give you a bit of intelligence. It'll tell you how many hours are either below the target or above the target. So once you look at that, you can say, well, okay, this zone is getting too cold, so I got to do something about that. Or this zone is too hot, and I've got to do something about that. And basically all it does is that the amount of time that you save, you can use that to improve the outcomes, particularly if you're looking at fairly big models, then the plugin becomes very useful. Okay, so having talked through this, let's go through a couple of examples and then we can have a bit of a question and answer session. So I'm going to pull up a model, and It's not a very simple model. It's a little complicated. If I go into so I've got a ground floor here, I've got a typical floor here, and I've got a top floor here. This is a kind of octagonal shape. You'll find buildings like this in Sydney, Brisbane, Melbourne, and this is built off the floor plan of a real building. It's been modified a bit, but very similar to a real building. So you can see here, let me just put this thing in plan. So I've got a number of zones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zones in each floor. All of these zones have got a fair bit of facade glass. We'll look at that in just a second. The middle is an unconditioned zone. I don't want to report that it's not conditioned, so I'll take that out of the equation. But just to see how the plugin works on this, if we go to the main activity screen on DesignBuilder, you can see that this is an occupied zone, and you can see here the name of the occupancy schedule has got the words class 5 in it. So the plugin knows that this is something we want to report on. The other, if you remember from the presentation, some of the inputs were what is the metabolic rate, and in the case of the NCC, the metabolic rate has actually been already specified within the code, and basically it'll be asking you for 130 watts, which is 75 plus 55, and let me show you that. Here we are. So the other thing that the NCC asks for is that there is a latent fraction of 55 watts, which is 42% of this total, which has been entered there. The other variable that you can look at is clothing. So there is a schedule here for clothing, and the schedule basically looks at how much clothing people are wearing in summer, winter, and middle seasons. And if you look here, you can see that I've got 0.5 for summer, 0.6 for the middle seasons, and 1 for winter. There is no particular guidance provided within the NCC, so it's up to you to choose what you would like people to wear. I've got thermostat settings here, and you can see here that I've got 21.1 and I've got 23, it should be 23.9, but I'll put that there. The reason I've got it to be 0.1 degrees centigrade more and less in the cooling instance is because energy simulations are iterative, and what happens is that whenever you see a number that is 24.0001, that'll be counted as an hour that the criteria is not met. So just to avoid some of those idiosyncrasies with the simulation model, I've just put it so that it captures all those ends of the spectrum. Now, I have used a real air conditioning system, a DTS compliant air conditioning system as required by JV3. I haven't put a complicated one because that's a completely different ball game, but just as a DTS system, I've just got a reverse cycle heat pump, which takes outside air. There's a cooling and heating reverse cycle coils. There's an electric defrost coil, and there's one in each of these zones. And that's sufficient for what I want to do, which is really look at the fabric. So I've done a couple of runs before. The model takes about 2.5 minutes to run. I will do one run, and then we can talk about, show you how the plugin actually develops that outcome, and then we'll go from there. So this one, what I've got here is on the construction tab, I've got an R1 wall, which is the minimum required. I've got a 3.7R on the roof. The rest is fairly straightforward. And then what I've done is for the windows, I think, let me see what I've got. Yeah, so I've got a 60% window to wall ratio. I've got a U value of 3.6 and a solar heat gain coefficient of 0.32. Okay, and let's go ahead and do this run. And this one, I've set it up so that some of the zones will fail in the criteria that we're being asked to meet. Okay, so let's go ahead and run it. I'm going to use Simulation Manager so I can do multiple runs, but I'll just do the one run. And while it's doing that run, there seems to be a few comments, so I can start maybe having a look at some questions if you guys have any questions. Okay, so can you, Preeti asks, can you elaborate on multi-classification? Is the plugin smart enough to simulate multiple classes? Yes, obviously. Rebecca, my colleague, has answered the question for you. Rebecca was the one who did all the programming for the plugin. You just, as she said, you just have to identify the building class for each zone, so you can have a mix of retail and offices and so on. And it will work out for each zone the correct number of hours that it's going to report the plugin on. Okay. Then Preeti has asked again, where is the met value defined in the code? Well, if you look, I think it's in, let me see if I can find it for you. I think it's in the JV3 where there is the definition for, let me go here. Let's find the actual code, but I think it's in JV3, specification JV3, that it tells you where to look for it. So let me open up my volume 1 while the run is going on. Here we go. Let's go to section J. It's actually in JV3 modeling profiles. I think it's right at the end where it talks about, oops. Okay, let's get it up here. Okay. So here is internal gains from appliances and equipment, and here are the internal gains from occupants. So for other applications, which means not dining rooms, restaurants, or cafes, you're asked to model this 75 watts of sensible and 55 watts of latent heat gain, which is 130 watts, and that's what I've put in. Okay. Now, a couple of other questions too. Let me just minimize this so we can see the progress. Okay, 20% complete. Now, Okay, Steve's asking, can this plugin be used for a building fabric assessment only using minimum DTS HVAC for both modeling runs? Yes, that's what it's designed to do. It doesn't matter what kind of HVAC system you use, whether it's a complex one or a simple one. You have to use a real HVAC system for JV3, which is what I've done. I've just used a pretty simple package terminal heat pump, but it is a real system. It's got all the part load curves, etc., that are required. Now, Cynthia is asking, how much weighting does each Pmv criteria get? Do the criteria that are specified by Section-J, like metabolic rate, get more weighting than, say, clothing, which the simulator can specify? How would the simulator know what clothing will be worn? Now, that's a very good question, Cynthia. There isn't, unfortunately, any direction provided within the Section-J as to what to use. Okay. So to some extent, you're relying on the modeler to choose sensible relationships for the variables that he or she decides to use. Now, typically, the conventional wisdom is that you would use 0.5 for summer. There we go. I'll show you a little bit of a calculator here. 0.5 in summer, 1 in winter, and there isn't really any direction at this point in time about what should be used for middle seasons. So you may want to use something like 0.7 or 0.6 or something like that. So for example, let's look at let's look at a winter situation. So I've got the metabolic activity around 1. I've got clothing at about a 1, which is a light business suit. I've got relative humidity anywhere between 40 and 60%. We'll just put it around 50%. And what we'll see is that we are being asked to maintain an air temperature of 21 degrees, but typically your radiant temperature will be less than that. So you can see here that unless you maintain a radiant temperature which is close to the air temperature, which means your fabric needs to be pretty good, you will very quickly fall below the -1. Now, just to maybe go back a little bit, when PME was developed, as I said, it has to do with the voting system, and it talks about the percentage of people who are dissatisfied in a space. So when you get to about -1, about 24–25% of the people in the space don't actually consider that to be comfortable. That's the limit that's being allowed for in the code. Now, if you reverse the situation and you made it, say, in summer, so you're being asked to maintain an air temperature of 24 degrees, and quite often your radiant temperature is significantly above that, your clothing level is lower, so let's say bring it down to about 0.5, you can see that that's not too bad. Now, by looking at these numbers, one of the definitions of PMV comes out, and that is that when a space is considered to be thermally neutral, about 5% of the people in the space don't particularly like those conditions. That's just the definition of it. You know, you can never get a space that's fully comfortable for everyone. Anyway, I was rambling a little bit there, but I hope that's answered your question, Cynthia. Now I'll come back to the other questions here, but now that I've finished this run, I'm just going to download this output file. and save it within the Energy Plus folder. And then we'll run the plugin just to show you how the plugin works. So when you install the plugin, you get this item called NCC 2019 Tools. And essentially you ask it to create a report. It tells you where it's going to create the report, and you go ahead and press yes. Now there's a little screen that comes up, which is on my second screen, and you guys can't see it, but it's telling me that there are 6,149 variables in the output file, and it's processing the file. So it's a largish file, and then it tells me it's extracting 60 variables from that, and here's the report that it's writing. Oops, it's come up on my other screen. Let me bring it here. Okay, so here's the report. It gives me the name of the building, tells me what's the location I'm using, what's the weather file that I'm using to do the simulation, when this report was generated, what are the clothing levels for winter, summer, what is the metabolic rate that's been used. And then this is a setting that actually asks the model to look at calculating the mean radiant temperature based on the surface with the largest window. That's particularly useful for buildings where you have big window sections going on. So the first section of the report is the temperature check. So the target temperature range is 21 to 24, and you can see here all 30 zones are being reported on. There's the zone name, the floor area, the fraction of the total floor area, what class of building it is, how many hours are being reported, how many of those hours are below 21 degrees, how many of them are between the 21 to 24, how many are above, and therefore the fraction, and whether the building has passed or failed. So in this case, the building has passed the temperature criteria. In fact, every zone has met the criteria. The next section of the report gives you the Pmv check, and this is a bit different. You can see here the target is -1 to +1. The building fails because only about 61.9% of the floor area passes Pmv. And when you start to look at the ones that have failed, you can start to make some commentary to yourself. You know, you have 4 hours that are below -1, but 61 hours above +1. So obviously this zone is warm. If you look at these zones here, the east-south zones, you can see here that these have got 95 hours below -1. So these are pretty cold zones. This one is a bit different. A third of the time it's cold, and 3 times that it's warm. Okay, and you can see here it's about 5% away from pass. Since you're allowed 2% out of this 2,610 hours, so about 52 hours is what you're allowed to be outside the Pmv condition to pass. So you need to do something about these zones. Okay, you got a combination of zones that are cold and warm. So obviously the radiant temperatures are not holding the correct range so that Pmv can be met. So you need to go and improve the fabric to be able to do that. So this is when you would go back to your model. You would then start to look at what are the things that you need to improve the building fabric's performance so that the Pmv would improve. You make those changes. You can rerun it, get an output. We can do an example. I've already set up one where I have got it to pass. And what I did is, I'll show you that. Essentially, I improved the window performance. I increased the level of insulation on the walls, and I increased the level of insulation on the roof. These were the 3 building envelope parameters that I had under my control, and that's what I've done. Now, a couple of things to kind of remember are that in the 2019 version of the code, it is actually the fabric stringencies have increased, particularly where the window to wall ratio gets higher. Okay. And what I'll do is I'll show you those changes. We'll start the runoff, and then I'll come back and answer some more of the questions that I can see here on the chat window. So just to show you, I've got a 2.8 wall from the R1 that I used to have. I've increased the R value of the roof from 3.7 to 4.2, and I've increased the window performance by lowering the U value to 2.8 and reducing the solar heat gain coefficient to 0.21. That's what I've done here. Okay. So if I rerun the model, and when the model's running, I'll come back and take some more questions. So let me just get this underway. Here we go. So while that's running, let me look at some more of your questions. Samuel has asked a question: is there any relationship between the inputs of the plugin and the choice type of weather file selected with respect to the outcome? The plugin simply reports what the outputs from the simulation are. So you can choose any inputs to the simulation. You can choose your weather file. It doesn't really care. It just looks at the zones that need to be reported and provides the output. Mahamadul Hassan has asked, the PMV requirement in NCC 2019 has asked for 95% of the area. If some spaces are unconditioned, then it can be excluded. That's correct. And that's what the plugin does. If you don't want to report certain zones that are not conditioned, you just include the words do not report. I'll show you that slide one more time. So if you remember, I showed you this slide, which was basically saying that if you didn't want to report a particular zone, which is unconditioned, you can just write the words do not report, and it won't include that in the calculations. Okay. So Fareen has asked metabolic rate from table 45 of ERA. Oh, yeah, so that's just the answer to the question that somebody else had. Thank you, Fareen. There's another question. Can you let us know why detailed HVAC system are used in the example and not ideal air loads? Because that is exactly what JV3 says. If you you have to do your analysis on a DTS compliant air conditioning system. If I can find my Section-J again. Hang on a minute. It requires for you to use a real air conditioning system with whether it's the DTS compliant or whether it's a proposed system. Each of your systems must have, says here, If you read these two highlighted bits, it talks about having part load performance curves as part of your system. So you cannot use an ideal system for doing JV3. Now, should that be the case is a different question. You know, the ABCB might in future say that, okay, if you only wanted to show the proposed, the performance of the proposed fabric compared to that of the reference fabric, you only need to compare the ideal thermal loads. That's a decision that they could take. It was put to them, but they have not agreed to that. So at this point, you need to use a real system. I should make a comment that there are tools around which provide outputs for idealized geometries and idealized systems. And unfortunately, those can't be used at this point for JV3. That's one of the advantages of DesignBuilder / Energy Plus. You are modeling your building, not some rectangle or U-shaped ideal building. You're modeling your particular building, and you are putting in a real air conditioning system to do the analysis as required by JV3. Okay, so we're about 60% there. Okay, it would be great if you can let us know why did you put setback temperature, which is a low number like 12 degrees Celsius. Okay, so it's not really part of this discussion, but I'll quickly just talk about that. In Australia, we don't use setbacks. So within your HVAC schedule, you either use a 0 to switch it off or 1 to switch it on. But in countries that are really cold or really hot, like in a really cold country like, say, Sweden, if it's minus 30 degrees outside, you don't want to switch off your heating system at night and come back tomorrow to your office building. It'll take you 4 or 5 hours to bring the building back up to speed. So instead, you set back the temperature from 21 degrees to 12 degrees, and then the building cools down to 12 degrees and the heating system kicks back on and keeps it at 12, so that the next day when you come, you're not trying to get it up from minus 10 degrees centigrade. And it's the reverse in very hot climates. You don't, well, some of the buildings don't actually get, the air conditioning never gets completely switched off. They just reset the thermostat during outside hours. Now, Andrew asks, what criteria does the plugin use to distinguish between conditioned and unconditioned zones? It literally looks at occupancy. So if it's an occupied zone and you've got a class in the occupation schedule, class 2, 3, 4, 5, 6, one of the NCC zone class types, it will report it. If you don't want it to be reported, uncheck the occupied box so it knows that it's not occupied, or write the words do not report in the name of the occupancy schedule. Okay. Now, Preeti's asked, in the example, the perimeter zones are separated by virtual partition. Is it because the mechanical system is zoned as per that, or BCA 2019 mentions separating the perimeter zone? So NCC 2019 doesn't specifically ask you to model perimeter and internal zones, but it does ask you to model it as per the mechanical zoning by the air conditioning engineer. And if it's an open plan office like the one I'm using, the mechanical engineer will use a series of perimeter zones to calculate system sizing and airflow rates and so on. Okay, so here we go. We've got this one done. So I'm going to download this file, and you can see that file is some 362 megabytes. So now, once I've done the run, I'm going to post-process it. And so it's going away and thinking about it. When you do it, you'll see a little dialog box come up. It's on my second screen and I can't pull it across. So apologies for that. Okay, so Andrew has asked a question which Rebecca has already answered. Okay, Marcus Strang. Marcus, I'm not going to tell you how to do the runs to get the compliance, but within the Energy Plus, you've got some very strong ways of writing schedules where you can decide almost for every hour what the clothing level should be. So you can certainly change the schedule the way you believe it should be done. Okay. What outputs need to be ticked in the simulation tab for the NCC tool to have the information requires to do the calculations? Okay, that's a good question, Alistair. I'll answer that in a second. And I think Rebecca's already answered that. If you go to, I'll show you where in a minute, but all the documentation is there for you to download. So let's just look at this result here now that we've done the run. So the temperature criteria is still being met. There's no problem with that. Now you can see that I've actually managed to get the PMV to pass. And while every zone has passed, you can see here that some zones are colder in the morning. So these, we'll have a look at this. The east-south zone has got 25 hours a year where it's too cold. And then some of the west zones, the west, say the west north and the west north one, have got temperatures where it's pretty warm, 25, 35 hours in a year where the PMV is more than +1. So that's the way you'd use the plugin. Let me quickly just go and we can have a look at that typical floor. So what it's telling us is that some of the zones which are on the south are cooler, and the zones that are on the north and on the west are getting to be too hot. So you can see here, and I particularly chose this model because it doesn't have sort of the 4 cardinal orientations. It's got these strange orientations, which are always a problem when you're trying to do air conditioning. Now, Rebecca's already answered Alistair's question, but I think what might be useful is that to probably show you where where you can find the documentation for that. So if you go to the designbuilder.com.au homepage and you go to the products page and go right down to the bottom, there is information about the plugin, and Rebecca's put in a whole series of things. The download, how to install, what's the documentation with it. There's a tutorial video, an example of the output that I've just showed you. You'll find there's a series of release notes, some software, what are the schedules that we are using to account for the PMV. Everything is in there. So hopefully that will give you as much as you need. Kareem, I think we can take that offline after completing the simulation graphs and not showing in the analysis. You probably have asked for simulations for hourly and not daily, and maybe the interval that's set in the in the screen are set for day, so you'll probably find that that's what it is. How does zoning impact Pmv? Is it an advantage to have more or less zones? Well, that's a pretty hard one to kind of say. I would say that as a guide, the Pmv is calculated on what's called the geometric mean of a zone. So it's probably not a good thing to have a very thin zone. It's probably good to have a zone which is at least 3.5 meters sort of wide, and the Pmv gets calculated at the center of that. Mike Smith asks, can you specify which results file the plugin analyzes in case the cache from the computer simulation has been cleared? So it's what's called the ESO file, which is the Energy Plus standard file. When you've completed a simulation, that file will be there in the Energy Plus folder. Let me show you that. So it's this one here. It's usually the biggest file of the lot. Okay. Right. Will the slides be available to attendees after this? Well, we haven't thought about that, but we might put it up on the DesignBuilder website. Yes. Now, Rob has asked, regarding the zoning, does ASHRAE standard 140 called up by the NCC call up set perimeter zone depths? I don't believe so. Okay, so the standard 140C is actually only being used to test the accuracy of the software. It's not, that's not the way the analysis has to be performed in the NCC. Now, I should let you guys know, Rebecca's just reminded me, that the plugin is available for free download where you can have 4 tries in the demo mode. So do, for those of you who've got a valid DesignBuilder license, please, if you're interested, please do go to the products page on designbuilder.com.au and you can download it, install it, read through the instructions, and have a try. Okay. So I think I've sort of covered everything that I wanted to. We're pretty much just over time. I'm conscious that I don't want to hold people up. There's a couple of last minute questions. Wrong reference should have been ASHRAE 55. Well, again, I don't believe that ASHRAE 55 really tells you how to zone a building. It talks about thermal comfort inside a zone. So with that, thank you very much for joining. I trust it's been useful, and we'll look forward to you guys using DesignBuilder in a useful way for your practice. Thanks so much, everybody. Talk to you guys later. Oh, and if you did like it, stick something on LinkedIn and we'll all say thank you to that. Bye, everyone.